All right, last video for scientific notation. I'm grouping together addition and subtraction because their steps are pretty much the same. So first one is to get a common exponent. You know when you work with fractions and you're adding or subtracting fractions, I can't add 1/2 and 1/4 right away. I need to get a common denominator, right? So I'd have to make it 2/4 plus 1/4. Now that's a similar idea here. I need to get a common exponent before I can do anything when I'm adding or subtracting in scientific notation. So what that means is, if you watch my video on fixing numbers in scientific notation, it's a similar concept. I need to adjust certain things in order to make the exponents match. So I'm going to go through this example and show you how. The question I have here is 4 times 10 to the third plus 5 times 10 to the fourth. So as you can see, the exponents do not match right now. I have a 3 and a 4. They're not the same thing. So I have the option. Do I want to try to make them match and both be 3's? Or do I want to try to make them match and both be 4's? I personally like to make them the bigger exponent, so I'm going to make this into a 4. Well, in order to make that into a 4, I need to add 1 to it. Well, if I'm going to add 1 to my exponent, if you follow this diagram, adding 1 to the exponent means I have to move my decimal place to the left. So I'm going to take my decimal place and move it to the left. So now my new number is not 4 times 10 to the third anymore. It's 0.4 times 10 to the fourth. And the other one stays the same. And that's it. That's step 1, getting my common exponent. Step 2, add or subtract the coefficients. Well, this problem we're adding, so we're going to add the coefficients. So I'm taking 0.4 and 5 and I'm adding them. Well, 5 and 0.4 is just 5.4. Step 2, complete. Step 3, keep the power of 10 the same. Remember how I just related it back to fractions? Once you get a common denominator, that denominator stays. Well, once I get a common exponent, 10 to the fourth, that's going to stay. So this is times 10 to the fourth. And again, step 4, this time I don't need to do it because this is in between 1 and 10. Now, if it ended up being too big, I would have to adjust. So let me try to come up with an example really quick to do one like that. Let's do 9 times 10 to the 7th. No. Let's do 9.3 times 10 to the 7th plus, let's do 8.4 times 10 to the 6th. So again, the steps are going to be pretty much the same thing until the very last one. Get a common exponent. Again, I can choose the 7 or the 6. I usually go with the bigger one, so I'm going to turn this into a 7. That means I need to add 1 to this exponent. And if I'm adding 1 to the exponent, I've got to move the decimal to the left. So it's turning into 0.84 times 10 to the 7th. Added to 9.3 times 10 to the 7th. Now the exponents match. I have a 10 to the 7th in both spots. Step 2, add or subtract the coefficients. So I'm adding 9.3 and 0.84. Might want to do that off to the side. Remember to make your decimals line up when you're adding. So I'm adding here, 0 and 4 is 4, 3 and 8 is 11, 1 and 9 is 10. That decimal comes straight down to make it 10.14. That was step 2. Step 3, keep the power of 10 the same, so it's just going to stay times 10 to the 7th. Now I do need to adjust because this is not in between 1 and 10. I need to move this thing over for it to be between 1 and 10. Make it 1.014. But if I just moved it to the left, look at my diagram, I have to add 1 to the exponent. So that's going to turn into 10 to the 8th. Now, I didn't do an example that showed subtraction. The only difference when doing a subtraction problem is that instead of adding those coefficients, I would just simply subtract them. So there's really no difference in the steps. You just have to recognize if your problem is addition or subtraction. All right, once again, if there's any steps or questions, let me know.